Hi, hello. Welcome to this new webinar. Thank you very much for attending. Today is the second webinar, so some of your typical questions will be answered, and at the end, if you want, you can place your questions, okay, or use the platform to place questions for next webinar. So some of the questions that you sent us was to how to change the material behavior. Default one is the linear behavior, but for the structural analysis, the analysis stress and strain diagram of the material, and other question that you have placed last week, but I forgot to explain it in the webinar, is if we have many different properties, how to modify them instead of one by one, to do all the modifications in just one step. How to import an external geometry, definition of the insert tool using inserted elements inside a host structural element, and the definition of parameters. If we open a software, I can, for the question of importing a geometry, we can, if for instance, IGS geometry from external CADs. Here we have surfaces. We can check the attributes of each surface if the units of the import file is correct or not. Here you have it, and you can of course clean and debug all your geometry and delete. Here, if we want to use just the areas and we want to mesh the surfaces, we just need one layer of shells, of surfaces, of areas, and we don't need the full volume. So we can just choose between the outer or inner surfaces and set a thickness in the structural element. So if we want to assign this first material and assign the same material to these three surfaces, and then define three shell structural elements and set here a thickness. Here I have my three structural elements. I can apply different controls if they are all selected, and I can define here my edge size to all of them, and just try to mesh it. I set a name and try one mesh. Here I show you at the same time how to modify the different meshing controls. You have by selecting the three structural elements and clicking here, and I can change my mesh. Okay, I have done it only in the for three surfaces. Okay, you can change, of course, always the thickness. You don't need to remesh if you just need to change the thickness or some of the reformant groups. Of course, if you are going to change the geometry or make the mesh finer or coarser, you just need to remesh. Another question was how to modify your material behavior if we have any model. Here we have a dam and it's on the soil, the terrain. We have many options to have our mesh. Here in materials, depending on the selected material, you have here in the constitutive law group, which is the stress and strain diagram, which is linear by default. And if we change to short-term loads diagram for concrete, we will see that for the analysis stress and strain diagram, we have other options depending on the selected code. Here in our data, as our the concrete material is a time-dependent material, I can change the properties if we are going to perform a activation and deactivation analysis with the construction stage or evolutive analysis. But I can change my behavior here in the grid. I can edit the points, as you can see. Of course, you can change always the units and the behavior. If you are going to set a nonlinear behavior, as in the different, you have a different nonlinear analysis of concrete in this free course for the crack analysis, and you have these three options to model your nonlinear concrete. If you have a soil or rock material, you have other options, different material models, Drucker-Prager, Cam Clay, Moore-Coulomb, Hoek Brown for rocks, nonlinear elastic, and hyperbolic. Usually, once you select one of the material models, you will need to set different properties. By default, for Moore-Coulomb and Drucker-Prager, there's a cohesion and friction angle. Some of the properties are already predefined, but you must change them to set the ones that you have in from your data. If you have another type of material for steel, you have seen this in the different examples as well. If you want to consider plasticity, you have bilinear, and if you want as well to consider dependence with the temperature, there's another option. But always you can see here, and there's a small hardening. You can see here because the values are not the same. There's a little hardening, but you can set the same values. If you want to set a slope from the bifurcation point to the final rupture point, you can set it. So it's always you can modify all your properties as you wish. How to define an insertion if you don't want to perform a congruent mesh or spend time meshing to make nodes from some entities coincident with other structural elements, with the nodes of other structural elements, and then merge there's an option which is the insertion, which is very useful when we have dissimilar meshes. I'm going to create an example. I'm going to insert some rebars in a solid. It's very similar to the examples that it's already available in the free course, but I'm going to show you one from an example from the beginning. I'm going to set my grid. It's very easy to set my box. I can do it manually here, or I can set it here. I'm going to set a 5. Here I have it. My grid. I'm going to top it up 15 centimeters. I'm going to set different lines here as my rebars. So here I have. If I if I leave my control button, I can define all my lines. My 5 rebar, and I have to define my materials. Just select the first one, and I need as well a section for my reinforcement. I'm going to set 20 millimeters, or all with the same section, and I don't need anymore I don't need this one. So here's my geometry, and I just need to create my structural elements. I'm going to select all of them, my 4 curves, and I will apply my controls. Instead of number, I'm going to set length. It's another way of defining the mesh in beams, as you have seen in the video classes. And for my concrete slab, I'm going to define a solid and set a mesh with the different size of the, so you will see that the nodes will not be coincident with the nodes of the rebar. And here I have my solid and my 4 reinforcing bars. Just need to mesh and set a name, always, and wait until we have the mesh. Well, you can see here, it's already done. You can change my colors here. As you can see, you can set this bigger if you want, just to see the rebars, or smaller, but here we have them. That mesh of are dissimilar from the rebars. You can see here, I can activate the nodes from one rebar, and you can see that they are not coincident. So if we don't want to change our mesh and make them coincident, I can use my insertion utility. And I need 2 things. The host elements can be many different elements, and now I have just one host element, which is the solid 3D. And now I have to select the inserted elements. You can do it sometimes you have some difficulties to select. So always use this to change for the next element or the next property to be selected. Because if you select other structural element before clicking the arrow, you will replace the first host element. So click solid, then next property, and now you can select the rebars, the process. It's easier sometimes, or you can hide the solid 3D, but I will select using the entities window, and you can check here that my 4 trusses are selected. They are highlighted in blue. Click OK, and that's it. I have my insertion defined. Sometimes you have to change the tolerance, but it's not, you don't need it. So that's it. I have my, if you want to solve your model, I have it, solve it here, I think, yes. You can set different boundary conditions and just a load and solve. Here I have them. I can check stresses and see if my insertion is correctly defined. If I plot here, I have my results, and I can check if my rebars are working as well, and the mesh is connected through coupling the different degrees of freedom from the rebars and the solid. And you can see that we have results in our trusses. Other utility that you have been asking was how to use parameters. You can use any parameter for any value, and you can use formula or even units. You can set here a value with dimensionless and set it here. So every time you change it here, it will be updated. And if you want to set here the different type, if it's a vector or integer or real number, and if you want to set as well units, here you have them. And if you set a unit, you must always use the same. It's case sensitive, so you must always respect all the letters. If it's if you use, you must type it exactly as it's defined here. And here you can change units always, and it will be updated here. As you can see here, I have defined 1 unit here, but regardless the units which are chosen here, it will be updated. So if you have any question, you can place your question using the tool of raising your hand, or using the chat if you want to ask any question while I continue with my slides. As you know, I just as a reminder the improvements of 2020 new CivilFEM version that you have them in your free commercial license or in your student license. Remind you the other way of learning the software, which is enrollment in the UNED to get fundamentals and theory with the in combination with the practical application of the finite element method and CEA simulation. And after this free FEM course for civil engineering, you can enroll in the advanced FEM course, which is available now. If you check in the platform, you will see it starts next week on June 2nd of June. Has a special price of 300 euros with through 2 months training. And well, I will just show you some of the contents of this advanced course. Besides the ones that you have already in the free course, you will get more capabilities and more tools to be explained, because as you know, all analysis in civil engineering or any other type of engineering have no limits. You can always go beyond, changing your material behavior, your linearities instead, and going to advancing to other non-linearity as contacts, construction states, for tunneling, dynamic analysis, or spectral analysis, harmonic analysis, and including seepage and thermal capabilities in this license. These examples are included, which are shown here. It's an oil and gas structure. It's a cycling load in a reinforced beam column connection. This is the hydration analysis of concrete, seepage, and an arc bridge construction stage, evolutive analysis. And well, we perform as well consultancy projects besides our training and development of software. So thank you very much. Always remind you to, if you want to complete our survey, it will take you just a couple of minutes for 7 simple questions. So it will help us to improve our software, our courses, and if you need more contents to be included or more webinars, please stay tuned, keep contact, and send us any of your suggestions. Thank you.